All right, we will now be learning how to solve rational expressions. So here's the strategy to solve rational expressions. Number one, first you need to list all of the restrictions on the variable. Avoid any values, which would mean that you're going to avoid any values that would make the denominator 0. So first thing we do is say, what can x not be? Second, we're going to clear the fractions by multiplying both sides by the least common denominator of all the rational expressions. So remember, rule 1, fractions suck, get rid of them. Number 3, then we just solve the resulting equation. Number 4, we have to reject any proposed solutions that's in the list of restrictions from step 1. So this is part of checking yourself. You do have to check yourself when we have rational equations. If there's a possibility that x can't be something, we have to check to make sure x isn't that thing. All right. So example number 1. So step 1, list all the restrictions. So we see that the denominator can't be 0. So if x is 0, then the denominator is 0, right? So restriction, x can't be 0. Right? Because whether it's x equals 0 or 2x equals 0, x is 0. Right? So x can't be 0, otherwise it would make the denominator equal to 0, which is a no-go. Alright, then we gotta look at the least common multiple, or sorry, least common denominator. I keep saying that, my bad. So we can see that there's an x in one of the places, so that takes care of these x's, right? There's a 5 by itself, and then there's a 2. So we see that the least common denominator is going to be 10x. So we gotta multiply all of the terms by 10x. Remember, if we multiply everything by something, it's going to be over 1. So for the first term, x's cancel and you're left with 10. For the second term, 10 can go into, or 5 can go into 10 2 times, 5 goes into 5 1 time. Right? So we get 2x plus x's cancel, and then 10 divided by 2 is 5, so 15. And then we just solve. So subtract the 15 over, so we get negative 5 equals 2x, which means x is negative 5 halves. Alright, so now we gotta check. Is this part of our restrictions? No, right? Because the restriction was only that x can't be 0. So that's not 0, so we have our answer. So our solution set is negative 5 halves. Let's do another one. All right, so for this case, restrictions. So when will the denominator be 0? Well, we can see the denominator is 4, so 4 is never 0. Again, 4 is never 0, and then 6 is never 0. So there are no restrictions this time, right? Because we don't have an x in the denominator. So let's look at the least common denominator. So 4 can go in, can make 2 and 2, and then 6 can be 2 and 3. So if we look at the first term, that's going to be 2 times 2. So we get rid of the first 2 from everything, and we get rid of the second 2. So the only thing left is 3. So we can see that the least common denominator is 12. So we get 12 times x over 4, 12 times 1 over 4, and 12 times x over 6. So the first term, we can see 12 divided by 4 is 3, so this is 3x. 12 divided by 4 is 3, so this is just 3. And 12 divided by 6 is 2, so 2x. Which means that x is 3. Go back and check your restrictions. There weren't any, so that's our answer. Our solution set is 3. All right, number 3. So, restrictions. So if we want to make sure if we want to make all of these fractions, right, we can always put this over 1. So we can see 1 is never 0, 2 is never 0, x could be 0, right, if x was equal to 0. So, restriction, x can't be 0, because if it was 0, the denominator would be 0. We can't have 0 in the denominator. Alright, we can look at the least common denominator. We can see that that's just going to be 2x, right? There's the 2, there's the x, nothing in common, so 2x. So, we multiply everything by 2x. So the first one, nothing cancels with the 1 because it's just 1, right? So you multiply across and you get 2x squared. X's cancel in the second one, so you get 2. And then 2's cancel, so you get 5x. So we get 2x squared minus 5x plus 2 equals 0. So we can use group factor by grouping, right? What two numbers multiplied gets you 4, adds gets you -5. And we can see that that's -4 and -1. So 2x squared minus 4x minus x plus 2 is 0. Group them up. Remember to include the negative. So we get 2x, x minus 2, minus 1, x minus 2, right? Then what's in common with both of these? It's x minus 2. Then we get 2x minus 1. Which means that in this case, if x minus 2 is 0, x is 2. In this case, if 2x minus 1 is 0, x is 1/2. So let's go back to our restrictions. Is either one of them 0? Nope. So both of those are going to be our solution. So the solution set is 2, 1/2. All right, number 4. So again, we can put it over 1. So restrictions. So what's going to make the denominator equal to 0? So the denominator of x plus 1, if that equals 0, we would see that x is -1. So x can't be -1, because if it was, the denominator would be 0, right? Alright, then we can see that the least common denominator is just 1 times x plus 1, which is x plus 1. So, multiplying every term by x plus 1, and we can see x plus 1's cancel on the top and the bottom, so we get 8x. 1 doesn't cancel with anything, it's just 1, so we can distribute that. So 4x plus 4. And then once again, x plus 1's cancel, so we get 8. If we subtract the 4x over, we get 4x. 4 minus 8 is -4, so x is -1. Go back to our restrictions. Ooh, x can't be -1. So this cannot be our solution. which means that the solution set is empty. Yeah, there is no solution for this problem. All right, number 5. Let's look at this one. All right, so restrictions. What are the restrictions? Let's look at each denominator. So the first one, x squared minus 9. What x's make that 0? So x squared could equal 9, which would mean x is plus or minus 3. Don't forget the plus or minus 3, which means x cannot be plus 3 and it can't be minus 3. So if you want to write that out like that, you can do that as well. For the second one, if x minus 3 is 0, x is positive 3. We already said it can't be positive 3, so that one's taken care of. And then we get x plus 3 equals 0, which would mean x can't be negative 3, which, again, already got that. Good. Okay, so now let's look for the least common denominator. We can see that the first one, x squared minus 9, that's just x minus 3 and x plus 3. Right? And the second one is x minus 3, which is just 1 times x minus 3, and then x plus 3, which is 1 times x plus 3. So for the least common denominator, right, we can see if we look at the first one, x minus 3, so all the x minus 3's cancel, x plus 3, all the x plus 3's cancel, and then we get 1, which is just anything times 1 is anything, right, is itself. So we see it's x minus 3, x plus 3. So that's what we got to multiply everything by. So 3x over, and again, we can, we don't have to do x squared minus 9 anymore. We can just do x minus 3, x plus 3. So we're going to multiply that by x minus 3, x plus 3. Plus, and then we're going to multiply 1 over x minus 3 by x minus 3, x plus 3. And then the last one, 3 over x plus 3. Oh, not 1, 3. There we go. All right, with the first term, we can see x minus 3's cancel, x plus 3's cancel, so we're left with 3x. For the second term, we can see that the x minus 3's cancel, so we get x plus 3. For the last term, we can see the x plus 3's cancel, so we get 3 times x minus 3. All right, we can distribute the 3. So 3x plus 3 is 3x minus 9. X plus x is 4x. So subtract, we get x on one side, on the other side we get negative 12. So let's go back to our restrictions. Negative 12 isn't 3 or negative 3, so we're all good. So solution set is negative 12. Problem number 1. So this formula models the cost in millions of dollars to remove X% of a river's pollutants. If the government commits $375 million for this project, what percentage of pollutants can be removed? All right. So Y is the cost, millions of dollars. So that's what the 375 million is, right? So 375 is 250x over 100 minus x, and we're trying to solve for x. So restrictions, we can see that since 100 minus x would equal 0, that would make x equal 100, right? So x cannot be 100. Since this is over 1, we can see that the least common denominator is just going to be 100 minus x. So we do 100 minus x times 375 and 100 minus x times 250x over 100 minus x. We can see on the right side those cancel, so you're left with 250x. On the left side, you get 37500, right? 35,500 minus 375x. All right, if we're going to add 375x to both sides, we see that we're going to get 625x. And then we divide. So x is going to be 37,500 divided by 625. All right. So how can we simplify that? Well, we definitely know that we can just divide it out. We can also try to break it up. So we definitely know that the top and the bottom can be divided by 5, right? So we can divide the top by 5, which would be 7, 5, 0, 0, right? Because that's just 25 and then zeros. So and then we get 625 divided by 5, so that goes into it 1 time. Bring down the 2. 5 goes into 12 2 times, which is 10. Bring down the 5, and then that would be 5. All right, I mean, we can keep dividing by 5s, right? So, especially if you don't have a calculator, this can be a good way to do it. 75 divided by 5, or actually by this point we can probably do 25s, right? Because 75 divided by 25, right? If you have 75 cents, how many quarters is that? 3, and then the 2 zeros. And if you have $1.25, how many quarters is that? That's just 5, right? And then we can see 5 divided by 30 is 6, so then divided by 300 would be 60. And since 60 isn't 100, right, we can see that it's going to be, the answer will be 60% of the pollutants can be removed. All right, let's look at this one. So this formula describes the selling price, the product's selling price, S, in terms of its cost of the seller and its markup rate. So let's solve the formula for R. So what that means is if we're going to solve the formula for R, we need to say R equals something. So first, right, you can see that R can't be 1, right? Because 1 minus R is 0. You just add the R to the other side. R can't be 1. We can see that the least common denominator is just going to be 1 minus R, right? So we can just multiply both sides by 1 minus R. For the left side, we can distribute that S, so we get S minus SR. For the other side, we can see we just cancel the 1 minus R's. So we can subtract by S, because remember we're trying to get R by itself. and then divide by r, or sorry, divide by negative s. Good. There we go. Remember, the only thing that we know about r is r just can't be 1, right? So because we still started with this formula, we still know r can't be 1. So what is the markup rate on the textbook costing the campus $140 and selling for $200? So if we have our formula, right, we can see that the campus, that's the C, right? So that's going to be 140 minus the selling price, which is 200, divide by negative 200. So 140 minus 200 is going to be negative 60 over negative 200. So negatives cancel. The first zeros cancel. We can see we divide the top and bottom by 2, right? So top divided by 2 is 3, bottom divided by 2 is 10. So r is just going to be 0.3, which means, well, first, make sure we check. Yep, r still can't be 1. It's not. It's 0.3, so we're fine. So the markup rate is 30%. Problem 3. So if you're wearing glasses, did you know that each lens has a measurement called the focal length, f? When the object is in focus, its distance from the lens, p, and the distance from your retina, q, satisfy this equation. So this is kind of what the, an example of the graph would look like. The object is p away, and from your retina, it's q away. And so it adheres to this formula. So for this formula, let's solve for p. So that means that we need to say p equals something. All right. Well, if we're solving for p, notice p can't be 0, right? So looking at the LCD, we can see it's just going to be p times q times f, right? Because there's none of those letters have anything in common. So we're going to multiply p times q times f by everything. So 1 over p plus p times q times f times 1 over q, and then p times q times f times 1 over f. So for the first term, the p's cancel, and we're left with qf. For the second one, the q's cancel, and we're left with pf. For the last one, the f's cancel, so we're left with pq. All right, so we can see you can just, if you want to get the p's together, right, we can subtract. So we can subtract pf minus pq, and then subtract the qf to the other side. So unfortunately, there's a p here and there's a p here. So how can we make it to where there's just one p? Well, since they both have a p in common, we can factor out a p, right? So we factor out a p, we get p times f minus q. So if we divide this by p, this is what we get, right? Woo! All right, so that might have been challenging for some of y'all, so let's do it again. Let's do, and this is the last example. So remember, if we're solving for y is the only variable here, right? The other two, you can kind of think of them as numbers. And if you want, you can actually rewrite them as numbers, just make sure that you actually don't, multiply the numbers. So if it's x times z, right? If you have 2 times 3, don't make it 6, just make it 2 times 3. So that way you have it 2 is x, 3 is z. Actually, we can do that if you want. So you can let x be 2 and 3 is going to be z. So this might be helpful for some of y'all who just really can't get past these numbers. All right, so we can see that the LCD is just going to be 2 times 3 times y. Remember, don't multiply these together. It's just separate because x and z are separate. So we multiply 2 times 3 times y by 1/2. 2 times 3 times y times 1 over y. 2 times 3 times y by 1 over 3. All right, so for the first one, 2's cancel, so you're left with 3y. For the second one, y's cancel, so you're left with 2 times 3, but remember we're not going to multiply that out because that just means x and z. So 2 times 3. And then for the last one, we're going to divide out the 3. So we get 2y. Okay, remember we need the y's together. So we can do 3y minus 2y equals 2 times 3. So we're moving this one to this side, the other one to the other side. So since both of these have a y in common, we can factor out a y, which will give us 3 minus 2. Remember, don't subtract because these are two different letters, right? In reality, they're letters, they're not numbers. We're just seeing them as numbers for now. So then when we divide, we see that y is going to be 2 times 3 over 3 minus 2. And again, that's not 6, right? We can't do 2 times 3 is 6, and then 3 minus 2 is 1. So you can't make it equal to 6 because 6 doesn't mean anything, right? We have to leave it like this. And since we said that x was 2 and z was 3, right? Just making sure that's what we said. Yep. So if you leave it like this, right, then you can see, oh, so our equation is just x times z over x minus z. Oh, sorry, z minus x. And there we go. So that's potentially another way you could do it if the letters are just messing you up. All right, that's it for this lesson. If you have any questions, as always, let me know.